Masaya mag-aral ng science with Sir Alvin Miranda.
Hello learners, welcome to my class. In this video, you will learn about light. Are you ready to learn? Let's go! Throughout centuries, a lot of prominent scientists try to explain light. Sir Isaac Newton believed that light behaves like a particle called corpuscles, while Christian Huygens believed that light behaves like a wave. A third scientist named Louis de Broglie came up with what is known as the dual nature of light. He explained that light can be a particle and can also be a wave. To complete our knowledge about the nature of light, James Clerk Maxwell proposed the electromagnetic theory of light. It depicts that light is a transverse wave composed of oscillating electric and magnetic fields which are at a right angle with each other and perpendicular to the direction the wave moves. While these scientists dig deep into the nature of light and how light is propagated, let us be familiar with ordinary materials we use as common sources of light. Can you name some sources of light? Sun is known as a natural source of light. Candles, lamps, bulbs are artificial sources of light. The light sources that emit their own light are called luminous objects or luminous materials. And those that do not produce their own light is called illuminated objects or materials, such as the moon, which only reflects light from the sun. In the absence of a luminous object, this object will not be seen. In order for us to see them, a light from luminous object must be reflected. Remember, energy transformation is needed to convert forms of energy to light. Example, in bulbs, electrical energy is converted to light energy. In lamps, chemical energy is transformed to light energy. The brightness of light depends on the source and the distance from the source. Brightness, however, is qualitative and is dependent to the person's perception. For instance, in our phone's brightness setting, we have different levels of brightness depending on our taste. Quantitatively, brightness can be expressed as luminous intensity with a unit known as candela. Luminous intensity refers to the amount of light power emanating from a point source within a solid angle of a steradian. Varied sources produce different intensity. Different distances from the light source provided varied intensity. As mentioned earlier, James Clerk Maxwell discovered the electromagnetic wave theory of light. He combined the concepts of electricity and magnetism to come up with his theory on electromagnetic waves. Since these are waves, they also exhibit the different characteristics of waves such as wavelength, frequency, and wave speed. There are different forms of electromagnetic waves arranged according to frequency. This arrangement of the electromagnetic waves is known as the electromagnetic spectrum. Electromagnetic waves are radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray, wherein radio wave has the lowest frequency and gamma ray has the highest frequency. Take a look at the table. What relationship can you observe between wavelength and frequency? Wavelength is inversely proportional to frequency. When there is an increase in wavelength, there is a decrease in frequency. Here are some applications of electromagnetic waves. Among these electromagnetic waves, light or visible light is the only one seen by our eyes. This visible part of the spectrum is subdivided into colors. If white light is shined into a triangular block of glass called prism, the glass refracts the light in an effect called dispersion. Dispersion is a phenomenon in which a prism separates white light into component colors. The electromagnetic has the following colors in sequence: red, orange, yellow, green, blue, violet. It can easily be remembered as Roy G. Biv. Take a look at the table below. Which color has the highest frequency? Which color has the lowest frequency? Which color has the highest wavelength? Which color has the lowest wavelength? Which color has the highest energy? Which color has the lowest energy? Objects appear to have colors due to reflection and transmission of light. The reflected color is the color of the object. Primary colors of light are red, green, and blue. Combining two primary colors will produce secondary colors, such as magenta, yellow, and cyan. Combining all primary colors using light will produce white. White and black are not considered as colors of light. White is the presence of all colors of light, and black is the absence of light. Remember, light travels in a straight path. All electromagnetic radiation moves at the speed of light for about 300 million meters per second in a vacuum. And that ends our video for today. Thank you for watching. Until next time.